on this recording, and then what I'll do is I will post this on the website, and it will be titled Identifying Proportional Relationships in Tables by Calculating Unit Rates.
So are you gonna make a bunch of these?
Basically every time I teach in a lesson, I'm gonna be making these, and I'll entitle them.
And then we could just look at things and see how you did it.
Yep, they'll be saved there. So maybe you didn't have a question because you weren't working on it that day, but 3 days later you're working on it. You can come and ask me again, because I'm not going to necessarily remember exactly if I did that video or not. So you could always check the website first to see if I already talked about it, but you can also come and ask me. All right, so
Okay.
I should have shared this, and then I need to drag this over here so I can see the problem again. All right. So the question was, for each table, determine whether it shows that X and Y are proportional. If X and Y are proportional, fill in the blank with a number in simplest forms. Okay. So what I'm doing is on my table, I'll just write this first table down. I have 8 and 2, 25 and 5, 48 and 8, and 77 and 11. Okay. And then on the other one, I have.
That one's not proportional, though.
What's that?
That one's not proportional.
Yep, just hold on a sec. I'm glad you see that. Next one is 4 to 6, and 10 to 15, and 16 to 24, and 22 to 33. Okay, so they want me to determine if it's proportional, and you're saying how are you deciding whether or not it's proportional or not?
The numbers it goes 4, or it goes 1 over 4, 1 over 5, 1 over 6, and 1 over 7, and it has to be all the same all the way through.
Okay, so you are setting up, and you are correct in setting up y over x, okay, because this gives us our slope, all right? And when my slope is the same in relationship to all of my points on all of my ordered pairs, then I know that it's proportional. That's one way to know that it's proportional. But it also has to do what? It also has to pass through the origin as well. So we'll look at that. So they're asking me to answer the problem, y is something times x. Well, that's really our slope-intercept form. That's our y equals mx right there, okay, where m is the same as my slope, okay? So for that first one, you're correct. We had 1/4. We had, or if we say y over x, 2 over 8 is reduced to 1/4, 1/5, 1/6, 1/7. All right. So not proportional because it changes every time. If we look at the next one, we have 3 over 2. We have 10 over 15. We have 24 over 16, and we have 33 over 22. Well, this is already reduced. If I look at this one and I divide both, oops, this should be 15 over 10, sorry. If we look at both of these, if I divide both by 5, 15
Oh, I know what I did wrong.
3, did you switch them? Did you say 2/3?
Yep, I did.
Okay, so make sure you have that y over x. We're going to see here as we divide them both by 8, and this by 11, we're going to end up with 3/2 every time. Okay?
Okay.
So then we know that it is proportional. So I am going to stop. You have any more questions on that problem?
Not on this particular one at the moment.
Okay, I'm going to